Our planet Earth is an active and dynamic place, constantly changing and evolving. We might experience it as solid and unchanging, but beneath our feet, a different story unfolds, one of continuous motion and transformation. Earth's outer layer is not one solid piece. Instead, it's broken into giant pieces called tectonic plates, which fit together like a jigsaw puzzle. Imagine a cracked eggshell, only these cracks are where the action happens, where the Earth's surface is most alive. These plates are enormous slabs of rock, constantly moving and interacting with each other, creating a dynamic and ever-changing landscape. They drift atop a hotter, softer layer within the Earth's mantle, which acts like a conveyor belt, slowly but surely moving the plates. The movement is slow, about as fast as your fingernails grow, but over millions of years, it reshapes our planet's surface in profound ways. This constant movement creates mountains, volcanoes, and earthquakes, dramatically altering the landscape and impacting life on Earth. It's a slow-motion ballet with dramatic consequences, shaping the very ground we stand upon and influencing the environment around us. Understanding these tectonic plates is key to unraveling the mysteries of our planet's past, present, and future, helping us predict natural disasters and comprehend the Earth's geological history. Imagine two conveyor belts facing each other, moving in opposite directions. These conveyor belts represent tectonic plates on the Earth's surface. As they move apart, new material rises to fill the gap. This new material is magma, which originates from the Earth's mantle. This is similar to what happens at divergent plate boundaries, where tectonic plates are constantly shifting and creating new geological features. Here, tectonic plates are moving apart, pulling away from each other. This movement is a slow but powerful process that shapes the Earth's surface. This movement creates space for molten rock from deep within the Earth to rise up. The molten rock, or magma, finds its way through the cracks in the Earth's crust. This rising magma, called lava when it reaches the surface, cools and solidifies, forming new crust. This process is essential for the creation of new land masses. This process continuously adds new material to the Earth's surface along these boundaries. Over time, this can lead to the formation of significant geological structures. The most dramatic example of a divergent boundary is the Mid-Atlantic Ridge, a vast underwater mountain range that stretches for thousands of kilometers. This ridge is a testament to the power of tectonic forces at work beneath the ocean. Iceland, a land of fire and ice, sits atop the Mid-Atlantic Ridge. This unique location makes it a geological hotspot, where volcanic activity is frequent and dramatic. The island owes its very existence to the divergent boundary beneath it. As the North American and Eurasian plates slowly pull apart, magma rises to fill the void. This magma solidifies into new crust, gradually building up the island of Iceland. Volcanic eruptions are a regular occurrence in Iceland, spewing lava and ash into the air and creating new landforms. The island's dramatic landscape, with its glaciers, geysers, and volcanoes, is a testament to the power of plate tectonics. While divergent boundaries separate plates, convergent boundaries bring them crashing together. Imagine two cars colliding head-on. The impact creates intense pressure and deformation. At convergent boundaries, the denser plate, often an oceanic plate, is forced beneath the other in a process called subduction. This collision generates immense pressure and heat, melting rock and creating magma. This magma rises to the surface, often erupting as volcanoes. The collision of two continental plates is a different story. Since both plates have similar densities, neither easily subducts. Instead, they crumple, fold, and uplift, creating vast mountain ranges. Section 5. The Himalayas, a monument to collision. The Himalayas, Earth's highest mountain range, are a testament to the awesome power of convergent plate boundaries. Millions of years ago, the Indian subcontinent began its slow-motion collision with the Eurasian plate. This collision continues to this day, pushing the Himalayas higher by a few millimeters each year. The immense pressure created by this collision has folded and uplifted the land, creating the towering peaks we see today. The Himalayas are a stark reminder that Earth's surface is constantly changing, shaped by forces that operate over vast timescales. Section 6. When oceans meet continents. When an oceanic plate collides with a continental plate, the denser oceanic plate is forced beneath the continental plate. This subduction process is responsible for some of the planet's most dramatic geological features. As the oceanic plate descends, it melts, creating magma that rises to the surface. This magma fuels chains of volcanoes along the edge of the continental plate. The collision also creates deep ocean trenches, some of the deepest points on Earth. The Pacific Ocean's Ring of Fire, a zone of frequent earthquakes and volcanic eruptions, is a prime example of the power of ocean-continent convergence. Section 7. The Ring of Fire, a tectonic showcase. Encircling the vast expanse of the Pacific Ocean is a zone of intense geological activity known as the Ring of Fire. This region is a hotbed of seismic and volcanic events, making it one of the most geologically active areas on Earth. This zone is a testament to the dynamic nature of plate tectonics, where the Earth's lithosphere is constantly in motion, driven by forces deep within the planet. The Ring of Fire is a direct result of plate convergence, where oceanic plates are subducting beneath continental plates. This subduction process leads to the formation of deep ocean trenches and volcanic arcs. This process creates a nearly continuous chain of volcanoes and triggers frequent earthquakes. The energy released during these events can be immense, causing significant changes to the landscape and impacting human settlements. The Ring of Fire is home to over 75% of the world's active and dormant volcanoes. These volcanoes are a mix of towering giants and smaller yet equally powerful formations, and is responsible for approximately 90% of the world's earthquakes. The seismic activity in this region is closely monitored by scientists to better understand and predict these natural events. It's a stark reminder of the powerful forces at work deep within our planet. These forces shape our world, creating both beauty and destruction, and reminding us of the ever-changing nature of Earth. Section 8. Sliding past. Transform boundaries. At transform boundaries, tectonic plates slide horizontally past each other. Imagine placing your hands flat together, and then moving one hand forward and the other back. The friction between the plates at these boundaries creates stress that builds up over time. When this stress exceeds the strength of the rocks, it is released suddenly, resulting in earthquakes. The San Andreas Fault in California is a well-known example of a transform boundary, where the Pacific plate slides past the North American plate. This fault is responsible for frequent earthquakes in the region, including the devastating 1906 San Francisco earthquake. Section 9. Understanding our restless planet. Tectonic plates are the key to understanding our planet's ever-changing surface. They hold the answers to why mountains rise, volcanoes erupt, and earthquakes shake the ground. By studying plate tectonics, we gain insights into the processes that have shaped Earth over billions of years. This knowledge is essential for understanding natural hazards like earthquakes and volcanic eruptions, allowing us to better prepare for and mitigate their impacts. So next time you feel the ground shake or see a volcano erupt, remember the powerful forces at work beneath our feet, the restless dance of Earth's tectonic plates.